In this video, we're going to talk about how to use the Schmidt Orthonormalization process. Suppose we're given a basis B. Let's use the Schmidt Orthonormalization process to turn B into an orthonormal basis. Let W sub 1 be equal to V sub 1, which is equal to our first vector, 3, 4. And let W sub 2 be equal to V sub 2, our second vector, minus the dot product of V sub 2 and W1 divided by W sub 1 times W sub 1, in other words, the dot product of W sub 1 times itself, all times W sub 1. Substituting our values, we get 1, 0, minus the dot product of 1, 0, and 3, 4, divided by the dot product of 3, 4, and itself, times 3, 4. Looking at the numerator, our dot product is equal to 3, and looking at the denominator, our denominator is 25. So now we have 1, 0 minus 3 over 25 times vector 3, 4. Simplifying further, we get, simplifying this expression further, we find that W sub 2 is equal to the vector 16 over 25 and negative 12 over 25. Now we go back and normalize W sub 1. So we have the square root of 16 25ths squared plus negative 12 over 25 squared I'm sorry, let me backtrack a little bit here. This is actually W sub 2. I'm going to erase this and we'll just go back. I would like to start with W sub 1. So, returning here, we have magnitude of W sub 1, which gives us the square root of 3 squared plus 4 squared. That's equal to the square root of 25, which is of course equal to 5. Then we normalize W sub 2. So we have W sub 2 is equal to the square root of 16 25ths squared plus negative 12 25ths squared. We can cancel our square root of a square. 16 25ths plus negative 12 25ths is equal to 4 25ths. I'm sorry, that's actually 4 fifths. And you can verify that using your calculator. Then we can take w prime of 1, which is the reciprocal of w sub 1. And since w sub 1 is 5, that means our reciprocal is 1/5. We multiply this by our original v sub 1, 3, 4, and our result is 3 over 5, 4 over 5. For w prime sub 2, we take the reciprocal of our magnitude of w sub 2, so 4 fifths is rewritten as 5 fourths, and we multiply this by w sub 2, which we obtained earlier, 16 over 25, and negative 12 over 25. Therefore, B prime, our orthonormal basis, is equal to our two new vectors, 3 fifths, 4 fifths, and 4 fifths, negative 3 fifths, which is obtained when we cross-cancel and simplify w prime sub 2. So we have our orthonormal basis. This concludes our basic example of how to apply the Gram-Schmidt orthonormalization process. I hope you found it helpful, and we'll see you next time.